Hello everyone, welcome to West Explains Best. Today we're going to be talking about complex numbers at the end of chapter 7, specifically 7.7. And today we're going to talk about the building blocks of what a complex number is. We can't go any further when talking about complex numbers than the imaginary unit. So the imaginary unit is like the building block of complex numbers. If we recall, we left in previous sections a lot of answers like this: no real solutions. And why is that? Well, that's because no number times itself twice can equal negative 16. No real number, that is. Because anytime we have a negative times a negative, it equals a positive. Positive times positive, clearly positive. So what on earth could we multiply together twice to give a negative? Well, that would be the imaginary unit. So the imaginary unit is essentially the basis of complex numbers, and it really helps us handle these negative roots. So we have negative square root of, the square root of -1, and that is going to be the imaginary unit. That is I. That's what we define as I, and this is where everything is built up off of. So this is the basis of the imaginary unit. Now, if we take the imaginary unit, square root of -1, and we multiply it by itself, what happens? Well, by the property of radicals, when we multiply a radical by itself, it undoes the radical, essentially. So we'd get -1. This is the same thing as I times I, so then we get I squared, which is equal to -1. So right here, we can write I squared equals -1. So it's interesting that if you have an imaginary unit, something that you can't take the square root of normally for any real number, but you multiply it by itself, you can get a real number. -1 is a real number. So with these principles, we can do a lot of manipulation with these equations, and it's very helpful. Imaginary units are particularly helpful for electronic and electrical engineering. So we're going to go ahead and show how you break down normal roots with negatives inside of them. So what you do is you write it like this. You write it as the product of square root of -1 and the product of square root of b. Once you do this, we already know what -1 equals. So the square root of -1 is I, and then we write radical b. And the radical b just stays inside, and that's the most simplified form. You can do this every time. So in this case, we have a negative out front. Doesn't change much. We can factor out the square root of -1, and then we have the c there. So then we just simplify. We get negative I radical c. So using these principles, we can take on a lot more problems than we could before, instead of just writing no real solutions. So moving on to letter A, we have square root of -100. So this can be broken down into square root of -1 times the square root of 100. We're going to write I for square root of -1, as we've learned, and then we write the principal square root of 100, which is positive 10. Now, you don't write it as I10. This isn't like an Apple device or anything. You're just going to write it as 10I. Very much in the same way that if you had x times 10, you would write it as 10x and not x10. So our answer is 10I. Now, let's say we have negative out in front. It doesn't change much. We write it as -1 times the square root. Square root of -1 times square root of 36. That's I times square root of 36, which is 6. Don't forget the negative. Sorry, I forgot the negative. So it's equal to -6I, and that's our answer. This one's a little bit more complicated, but nothing too bad. There's just an additional step, which we've learned before, using the factor tree method. This is equal to the square root of -1 times the square root of 54, which is equal to I times the square root of 54. Now, we need to simplify square root of 54 here. Square root of 54, we need to use the factor tree. Now, I talk about this extensively in other videos, but I'll give you kind of the groundwork here. So anytime we have a square root, we're looking for any time we see a pair, the same number twice. So here we see that we have 2 3s. Actually, we have 3 3s, but this one is by itself. It doesn't have a pair, so we square it. It's not square it, but we put a box around it, put a box around it, and these are going to stay inside the radical. These ones stay inside the radical, and they get multiplied. This one has 1 3 leave the radical. So we can write this as 3. The 3 leaves the radical, 1 3 does, and then we have 2 times 3 left inside the radical. 3 radical 6 is a simplified form of that. So this is going to be equal to, if we continue, I times 3 times radical 6. We're going to put it in the correct order, 3I radical 6, and that is our answer. So it's not too bad. You just have to break it down into one additional step. Otherwise, it's the same as simplifying radicals, which you talk about in the earlier sections. Now, let's say we're multiplying radicals of negative numbers. We can't apply the same rule we used to. So before we could do something like this. If we have square root of 9 times square root of, well, let's do 4. Let's keep it consistent. Square root of 9 times square root of 4, we could multiply the same numbers underneath the radical, get square root of 36, and we get 6. Now, why can't we do that here? Well, if we multiply negative 9 times negative 4, we get positive 36 again, and we get 6. Now, how do you explain that we get the same answer for these two? If one has negative numbers, which are imaginary, and the other one has positive numbers. Okay, that can't be rationalized. So this rule that we expressed here only works for positives. So this is only for positive numbers. So we can't do that with negatives. So don't get in the habit of doing that with negatives. The first step in handling these problems, and all these problems with imaginary numbers, first step is to take out I. Okay, so we're going to take the I's out first. I know that sounds like a violent, like military move or something like that, but we're trying to simplify here, and that's the most efficient way, is taking the I's out first. So here we're going to break this down just like we did before into its negative radical component and its positive radical component. So we have negative square root of negative 1 times square root of 4 times square root of negative 1 times square root of 9. Once we do this, we recognize that this is I. We know this is 2. Then we have I, and then this is 3. This is where it gets, we haven't done this yet. So we're going to multiply the 2 and the 3. That gives us 6. And then we have I times I, which gives us I squared. And this is why this was important. Up here we express that I squared is equal to negative 1. So that's what we're going to write here. 6 times, and we write negative 1, because that's what I squared is equal to. And we write negative 6. So understanding the properties of I up here is very important because it helps us with some of these more complicated problems. So that seems to make sense, that if the positive square root of 9 and positive square root of 4 gives us positive 6, then the negative version of those numbers gives us a different answer, in this case negative 6. We're going to apply the same process here. Now, if you're getting sick of taking out the negative 1 each time, oh, I was using green. I should go back to that. So if you're getting tired of taking out the square root of negative 1 each time, just know that a negative 1 is going to turn into I. So what we can do here, instead of writing the square root of negative 1, we can, once you get comfortable with it, you can write I square root of 7. Because you know that 7 with the negative comes out of the radical as I, and the 7 stays inside the radical. So that's another way you can kind of bypass writing too much all at once, and writing too much and kind of dragging you down a little bit. So here we're going to multiply the i's together, we get I squared, and because these are positive, we can multiply them together, we get square root of 21. We know I squared is the same thing as negative 1, square root of 21, negative square root of 21 is our answer. Okay, so we're going to split this up. Again, I'm going to take my shortcut this time. So I'm going to take I square root of 2, I square root of 8. I times I gives me I squared. I can multiply the radicals underneath. I get square root of 16. I squared I know is negative. Square root of 16 I know is 4. And there's my answer. These next couple, again, we're going to stick to the game plan. This game plan is first step is to take out the I. So we're going to take the i's out of both the top and the bottom. Once you do that, you can see that we're going to cancel out the i's. And now we're left with square root of 75 over 3. Normally what you can do is you can multiply both the top and bottom by square root of 3. That's generally how you do get simplifying with a radical in the denominator. But in this case, I'm going to put it all underneath one radical because I recognize that 75 divided by 3 gives me a perfect square, 25. So then I can just simplify this and I get 5 for my answer. We do a very similar process with letter E, but this time we first, again, take out the I. This time we can't cancel the i's. So we're going to go down here. I recognize that I can do 32 divided by 8. It gives me a perfect square. So I square root of 32 divided by 8. That's I radical 4. I times 2, 2i. And there's my answer. Okay, so this is going to be the end of this first video. We're going to move on to complex numbers in the second video, so stay tuned and see you next time.